So welcome students. So in this question you're given a quadratic equation x square plus sine theta plus cos theta into x plus 3 by 8 is equal to 0. And it's given that the both roots of this equation has to be positive and distinct. If that is so, what are the possible values of theta? So what are the conditions which ensure that the roots of the quadratic equations are both positive and distinct? So the simple conditions are the roots have to be real first. It's given that it is distinct. So the discriminant has to be greater than 0. That's the first condition. Because if the discriminant is less than 0, there is no argument about the roots being positive or negative. This is the first condition. And the second condition is that the sum of the roots as well as the product of the roots both have to be positive. So if the product of the roots is positive, it ensures that the roots are of same sign. And if the sum is positive, it ensures that both are of positive sign. So these are the three conditions which need to be valid for the roots to be both positive. So now what is this? Where does theta lie for these conditions to be valid? Discriminant is sine theta plus cos theta whole square b square minus 4 into 3 by 8, that is 3 by 2, is greater than 0. That is, sine theta plus cos theta whole square should be greater than 3 by 2. Sine theta plus cos theta whole square should be greater than 3 by 2. So this implies, so let us try to solve this later. Sine theta plus cos theta whole square should be greater than 3 by 2. Next, what does this condition say? Alpha plus beta is greater than 0. That is, minus of sine theta plus cos theta minus b by a should be greater than 0. That means sine theta plus cos theta should be negative. And alpha beta is greater than 0. Alpha beta is 3 by 8. It is already greater than 0. There is no argument about this. So this is always true. So now the conditions that need to be valid are b square greater than 4ac, that is sine theta plus cos theta whole square is greater than 3 by 2. And the second condition is sine theta plus cos theta is less than 0. So these are the two conditions which are valid. So now let us try to solve each of these conditions. So first, sine theta plus cos theta is less than 0. Sine theta plus cos theta is less than 0. So how do we solve this? Let us try to convert this into a single trigonometric ratio. So let me do by root 2 into root 2. So it's nothing but root 2 times, so sine theta cos pi by 4, sine theta into 1 by root 2, sine theta cos pi by 4 plus cos theta sine pi by 4, that is sine of theta plus pi by 4 is less than 0. This is the first condition. The second condition is sine theta plus cos theta whole square is greater than 3 by 2. So again, let us divide this with root 2. If I divide this with root 2, I need to divide this with 2 because it's whole square. So this implies sine of theta plus pi by 4 whole square is greater than 3 by 4. So this implies sine of theta plus pi by 4 is either greater than root 3 by 2 or less than minus root 3 by 2, right? So if x square is greater than a square, so x can be either greater than a or x can be less than minus a. So these are the conditions which I need to check. So let us check each of these conditions. So to do that, so what I try to do is, so let me draw the graph of root 2 sine theta plus pi by 4 and sine of theta plus pi by 4. Let me draw both the curves and check the numbers for which this is valid. So let us try to solve these equations. To solve these equations, let us draw the graphs of y is equal to root 2 sine theta plus pi by 4 and y is equal to sine of theta plus pi by 4. So how do we draw the graphs of this? So simple, these are graphs related to sine theta. So these will be wavy curves, that is, they look like sine. And sine theta plus pi by 4, this is nothing but the graph of sine theta gone back by pi by 4 units. So the simple way to draw this graph is you draw the coordinate system, plot the point 0, pi by 2, pi, 3 pi by 2 and 2 pi. Next, so just find the values of this curve, find the values of this y at different values of theta, that is theta and the value of y. So when theta is equal to 0, y is root 2 into sine pi by 4, root 2 into 1 by root 2, the value of y is 1. It is, the value of y is equal to 1. When theta is equal to pi by 4, sine pi by 4 plus pi by 4 is pi by 2. So root 2 into sine pi by 2 is root 2. That is, when x is equal to pi by 4, the value is equal to root 2. Similarly, when x is equal to pi by 2, the value is 1 again. So if you go on finding the values of this curve at regular intervals of pi by 4. So I have found it at 0, pi by 4, pi by 2, 3 pi by 4, pi, again 5 pi by 4, 3 pi by 2, 7 pi by 4 and 2 pi. I have calculated the values of y and found the points and have joined them with a smooth curve. So that is the graph of root 2 times sine theta plus pi by 4. Next, I have drawn the curve sine of theta plus pi by 4. So y is equal to sine theta plus pi by 4. There is no root 2 here. So this curve varies only between minus 1 and plus 1. The range is minus 1 to plus 1. So now if you plot this curve, this is nothing but a miniature curve of this. So the amplitude just reduces by root 2 units. That is, this curve is the same curve but varying in between minus 1 to plus 1. So here also just put different values of theta and you get different values of y. So I have got the points. At regular intervals of pi by 4. So I have joined these points. So I got the curve sine of theta plus pi by 4. So now once I have this, so first condition is that root 2 times sine of theta plus pi by 4 has to be less than 0. That is, the bigger curve has to be less than 0. That means I am looking at the points between 3 pi by 4 to 7 pi by 4. So between these points the curve is below x-axis. Outside these points the curve is above x-axis. So I am looking at the solution between 3 pi by 4 and 7 pi by 4. That's the first answer. Next, sine theta plus pi by 4 has to be greater than root 3 by 2 or less than minus root 3 by 2. So first let us try to see where sine theta plus pi by 4 is equal to root 3 by 2. So sine of theta plus pi by 4 is equal to root 3 by 2 implies theta plus pi by 4 is equal to either 60 degrees or 120 degrees. Right? Root 3 by 2 corresponds to 60 and 120 in the first and second quadrants. So theta is equal to pi by 12 or 5 pi by 12. So that is, so if you want my sine theta plus pi by 4 has to be root 3 by 2, the values of theta corresponds to pi by 12 and 5 pi by 12, that is 15 degrees and 75 degrees. So you have 75 degrees here, 15 degrees here. So these are the two values of x correspond to the value root 3 by 2. So now between these two values, that is pi by 12 and 5 pi by 12, between these values, as you can see, the graph is above root 3 by 2. That is, between these values, the value of y is more than root 3 by 2. That means the answer to this first inequation is theta lies between pi by 4 and 5 pi by 2. Now let us go to the second inequation. Sine theta plus pi by 4 should be less than minus root 3 by 2. First let us see where this is equal to minus root 3 by 2. So if sine theta plus pi by 4 is equal to minus root 3 by 2, minus root 3 by 2 corresponds to 4 pi by 3 and 5 pi by 3. That is 180 plus 60 and 360 minus 60. These are the two values. So correspond to this, theta is equal to 13 pi by 12 and 17 pi by 12. So you get two values somewhere here. So you have 13 pi by 12 here and 15 pi by 17 pi by 12 here. So at these two values, again, at these two values, so this is 3 pi by 2, this is 7 pi by 4. So this value, okay, this value will be less than 3 pi by 2, that is this value will be somewhere here, not here. 17 pi by 12. So 13 pi by 12 and 17 pi by 12. These are the two values where the value of the curve is in between, is exactly equal to minus root 3 by 2. So now I want the value of y less than minus root 3 by 2. That is, the graph should be below this. That means my theta belongs to 13 pi by 12 and 17 pi by 12. So the answer to this inequation is theta belongs to pi by 12 comma 5 pi by 12 or 13 pi by 12 comma 17 pi by 12. Now the answer to the first inequation is in between 3 pi by 4 to 7 pi by 4 to 7 pi by 4. So what is the common solution? Obviously this does not come in the common solution because the first solution is this interval and the second solution is the combination of these two intervals. So this does not come in the common interval. So this should be the answer. That is 13 pi by 12 to, so theta belongs to 13 pi by 12 comma 17 pi by 12. That's the answer to this question. Thank you.